Hello and welcome to your geometry recording. We are in week 9. So make sure this week when you go into the folder to do your key phrase assignment, you're doing the key phrase assignment for week 9. So I want to start up with a warm-up question where we are looking at a circle graph that tells us the music preference of students at a certain school. And in a circle graph, we're only given the percentages of students who like each type of music. And my question to you is, how can you use those percentages to help you figure out this warm-up question? And the question is, if 400 students were surveyed, so a total of 400 students, how many students choose country music as their favorite type of music? So how many are choosing country as their favorite type of music? And again, that's based on if there was 400 total students surveyed. So let's open our math notebooks and answer this question in your math notebook. I do want you to click pause and try this on your own. Again, actually taking good notes and trying these practice problems on your own, you're going to get so much more out of these recordings and make it more worth your time by actually pausing the recording and trying the questions and using that opportunity of checking your work with mine. So at this time, go ahead and click pause and try this question on your own. And then when you're ready to check your work with mine, you know the drill, click play. So remember, when we want to find the percentage of a number, what we do is we take the percentage and turn it into a decimal. So in this case, we're focusing on country. So 12% as a decimal, we move our decimal 2 places to the left, and it becomes 0.12 or 12 hundredths, 12 hundredths, and we take that number and we multiply it by the total number of students surveyed. So we're gonna take 0.12 12 hundredths times 400. And when we do that, we get 48. So that means that 48 students chose country as their favorite type of music. So to find the number, you take the decimal, take the percentage, change it to a decimal, then multiply that by the total number of students. And we could do that to find out the number of students out of that 400 that liked any kind of these music choices. So that's a good review from last week. You will possibly see a question like that on the Unit 6 test, so make sure you understand that. What are we doing this week? So in the beginning half of Unit 6, we focused more on finding the probability of different situations, where in the latter half of Unit 6, we're more looking at how we can take data and display our data. So instead of just having it listed in a column of numbers, how can we take our data and display it in a format that's more pleasing for us? It's easier for us to look at it and see trends, and that's what we're doing in the later part of Unit 6. So we're going to finish out Unit 6 this week. We're going to look at frequency tables and histograms, and then we're going to finish out this unit by looking at misleading graphs. I got a little bit ahead of myself last week in the recording, talked a little bit about misleading graphs. So we're going to continue to talk about those this week, and then we're going to take the Unit 6 test. Then we're going to take the Unit 6 test this week. So before I get into frequency tables, misleading graphs, I did want to talk about the Unit 6 test and probability. And just remind you, when you see that word "and," when you're trying to find probability and they ask you "and," that's really when you want to decide if it's an independent or dependent event. And then you're going to be multiplying your probabilities together. Where when you see the word "or," when you're asked to find the probability of something or something else, that's when you decide if it's mutually exclusive or mutually inclusive and follow the formulas. But you're always adding when you see the word or. So just a quick reminder as you start preparing for the Unit 6 test, some of those key words, what you're going to see, and what function you want to use. Alrighty, so looking at frequency and histograms from session 7. So frequency tables allow us to take our data and create intervals and then let the reader see how often somebody chooses or data falls into each interval. So let's take a moment and create a frequency table, and then from that create a histogram. So we'll see an example of this. So what is our situation? We're at a recent chess tournament, and all 16 of the participants, so we've got a total of 16 participants, had to fill out a form that gives their name, addresses, and age. So we're going to focus on the age piece. The ages of the participants were recorded as the following. So we've got 16 different ages listed. So right now, look at this list of ages. Can you look at that list of ages and tell me, what the most common age is? Can you tell me? It's kind of hard to say, well, the most common age you look through. It takes some time to really look through and figure that out. So let's put it into a frequency table so that we can examine our data a little differently and see some trends quicker rather than just look through this list of ages. So what we do for a frequency table is first we need to establish what our intervals are going to be. So we're going to divide our ages into intervals, and the intervals need to be the same amount for each interval. So our first step is let's identify the least and greatest age, or the oldest and youngest person. So there's our step one, and in this case, the least and greatest values would be the youngest person and the oldest person. So let's look through here. I see 36, that looks pretty young. Is there anything younger than 36? Oh, 34. So it looks like 34 wins out as the youngest person. What about the greatest value? So this is the least value. What's the greatest value? So I'm looking through 76. Is there anything greater than 76? It doesn't look like it, so that's the greatest value. So I'm just doing this, the least and the greatest value, so that I know what my intervals, where they need to start and finish, and we need to make sure they include the numbers 34 all the way to 75. So my intervals now need to be equal. So I need to divide my data into equal intervals. So what do I mean by that? So I could say that my first interval, might be ages 30 to 39. So here I've included the ages from 30 to 39. So that's 10 ages there. If you count starting at 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, that's 10 different ages there of years. So then my next interval would be 40. It would have to include that same 10 years of age. And then I could keep going here with this pattern. Now, you could use a different interval. If you wanted to do like 30 to 34 and then 35, you could make them different if you wanted to. The key is that the intervals need to be equal. They need to all include the same number of years. Then we're just going to now count the number of data values in each interval. So what I'm going to do, so I'm going to start with my first age here, 36. And so that's going to fall, there's one person in the 30 to 39. Then I go to my next value, 48. I put a tick in the 40 to 49 interval, 54, a tick here. 57 falls in this category as well, or interval, so I put a tick there. Move on to 63. That's going to fall in this interval. And I'm just going to keep on going. So I'm just going to keep on putting ticks. 76, this interval, and I'm going to cross them out as I go so that I know I've done them. 62, 52, 44, 34, 55, 58, 59. 59 falls in this category right here, 50 to 59. It's included in there. And then 75. So now I can see that a majority of my players are falling in that age range from 50 to 59. And I can kind of see patterns a little bit more clearly rather than just looking at a list of numbers. So I might be able to use my frequency table to answer questions like this. How many players were 50 or older? So instead of looking and counting, what I can do is look at my frequency chart. How many were 50 or older? So what I'm going to do is I'm going to count the number of players that fall in the categories that are 50 and older. So I see that there's 5, 6, 7, 8, 9, 10, 11, 12. So there would be 12 players that were 50 or older, and I could quickly figure that out by looking at my frequency table. So that's what a frequency table looks like and how we set them up. So from a frequency table, we can now create a histogram. So I'm going to create a histogram on this same slide, but what I'm going to do is I'm going to cover up this information right here. So if you want to, if you're not done taking notes, you want to take down the steps to create your frequency table, go ahead and click pause so that you can copy these steps down now, because I'm going to cover them up. So go ahead and click pause now. So what is a histogram? So a histogram looks very similar to a bar graph. So a histogram is a bar graph. It's a type of bar graph that's used to display the frequency of data divided into equal intervals. So instead of our bar graph being labeled with one value for each bar, we're now going to have an interval instead. And then in bar graphs, the bars are separated from one another. There's a little space between each bar, where the bars in our histogram are going to be of equal width, and they're going to touch. So let's go ahead and take our frequency table of our ages, and let's turn it into a histogram. So the first thing I did is I set up my X and Y axis. My X axis is going to be my ages, and then your Y axis is always going to be the frequency. So now we're just going to put in the bars. So let's go with creating different colored bars. And let's start with the 30 to 39 age group. So 30 to 39, how many people? There was 2 that fell into that interval. So there's my bar. Now I'm going to make a bar for my 40 to 49-year-olds. So remember, the bars here are going to actually touch, where in bar graphs they do not. Here they actually will. We also had 2, so they're going to be right next to each other. So notice my bars are labeled by the intervals, rather than like a category for bar graphs. Usually it's labeled by just categories. 50 to 59, that was our biggest number of frequency. We had 6, so let's change our color and do 6. So the width should be the same width. It's a little hard for me to do on here, so bear with me. They're touching, they're about the same width. 60 to 69, I'm going to finish this up now. So there is my histogram. So it looks like a bar graph, but it's a little bit different because instead of each bar being labeled by a category, it's being labeled by our intervals. And then our bars are going to touch instead of having a gap between them like they do for a bar graph. So that's our big differences here, that our each of our bars are labeled by an interval and that there are no gaps. So I'm going to move on. Misleading graphs. Again, we chatted a little bit about this last year. We looked at this exact graph where we looked at the U.S. unemployment rate. So ask your question, or ask yourself these questions. When was the unemployment rate higher, looking at this bar graph? So look at this bar graph. See how it's just got a there's a space between them. That's different than a histogram. And our bars are labeled by a category rather than an interval. So this is a bar graph. So we can see that this bar here is higher. So it looks like the unemployment rate was higher during the Clinton years. How much more? So looking at the bar graph, how much higher is this bar graph than this bar over here for the Bush years? So to me, it looks like it's like 3 times bigger. So it looks like the unemployment rate during the Clinton years was 3 times greater than during the Bush years. But is that true? So now I go to the next slide where the unemployment rates are actually labeled. So this is 5.2052, where this bar is represented by 5.1852. And just to point out that it would be helpful on this chart if they told us what these numbers represent. If it's a percentage, what it is. So I'm assuming that these are percents. And looking at this, look at how close these numbers actually are. They're very close. But looking at the bar graph, it appears as if they're not this close. And this is an example of a misleading graph. It makes us believe that the unemployment rate in the Clinton years was much greater than in the Bush years. But when we look at the actual numbers, we're seeing that they're very close. So how did they achieve this? How did they make it so this bar looks so much bigger? Well, look over here at our scale. So our scale doesn't start at 0. It starts at 5.17. So they're using a very small scale. And when you use a very small scale that also does not begin at 0, it makes the difference appear a lot greater than they actually are. So one way to create a misleading graph is to use a very small scale, and then also a scale that does not start at 0. Does not start at 0. So those are 2 ways that we can create a misleading graph. And why might we want to create a misleading graph? So if you want to make something appear bigger than it is, so let's say you're a proponent of Bush, you might want to make it look like during the Bush years the unemployment rate was much smaller. So you might want to create a graph that's a little bit misleading. So sometimes if there are reasons why people want to use misleading graphs. It's not the most honest thing to do, though. So look at these 2 graphs here. These 2 graphs actually represent the same information. And that's the increase in house prices per year. So look at this graph. It looks like the increase in house prices per year from 1998 to 99 is very great. It looks like, wow, there's a really big jump in house prices from 98 to 99. But come and look at this graph. Look at how close the bars are. And it represents the same information. But look at the scales. So the scale over here on the left, where our graphs look to show a big difference, does not start at 0. Look at the scale. It doesn't start at 0. Where over here, our scale does start at 0. So another way that we talked about having a scale that doesn't start at 0 makes makes your differences look a lot more dramatic than they actually are. So that is it. We're going to stop here. I'm going to put up the key phrase assignment. So in this session, we created a histogram from a frequency table. And I want you to tell me, they look pretty similar to bar graphs, but they are different. So how are bar graphs different from histograms? That's what you need to tell me for your key phrase assignment. And that's it. Have a wonderful rest of your week. And as always, I'm here to help you. So if you have any questions, let me know.